I welcome you all for this lecture series on artificial intelligence and machine learning. In this lecture, we will see the example problem for the informed search type, one of the type of informed search, greedy best first search. Greedy best first search, GBFS, is a powerful and efficient search algorithm used in artificial intelligence. It expertly explores a graph or tree by selecting the next node based on the heuristic function. The algorithm is called greedy. Why? Because it always chooses the node that appears to be closest to the goal without considering the long term consequences of its choice. This greedy approach allows the algorithm to find solutions quickly and efficiently. Greedy best first search is remarkably simple to implement and computationally efficient, making it an excellent choice for solving complex problems. We'll see the problem. Before going into the problem, we'll see the what are the steps to be followed in greedy best first search. So in this case, the first step is the initialization. In this initialization, the step marks that is the beginning of the greedy best first search algorithm. We start at the initial node, often referred to as the start node. We are calling it as the initialization node. We are calling it as the start node. We start at the initial node, often referred to as start node. This node is placed in the open list. This list is the placed in the open list. We'll write it in the problem. A collection of nodes that are known but have not been explored. The closed list, on the other hand, is initially empty. Closed list is initially, we are keeping it as empty. This list is used to track nodes that have already been fully expanded or and explored. By separating nodes into open and closed lists, the algorithm can efficiently prioritize which nodes to explore next while avoiding revisiting previously explored nodes. This setup lays the foundation for the algorithm's search process. The next step is the select the node to expand. In the selection step, the algorithm chooses the next node to expand based on the heuristic value of the nodes in the open list. The heuristic value, it is denoted as h of n. It represents an estimate of how close a node is to the goal. In the greedy best first search, the node with the smallest heuristic, smallest value is chosen as it is assumed to be the closest to the goal. By always selecting the node that seems nearest to the goal, the greedy best first search tries to prioritize paths that will likely lead to the goal more quickly. Once a node is selected, it is expanded by evaluating its neighbors or children, which are then added to the open list for further exploration. Next step is the expand the node. Once the node with the smallest heuristic value is chosen, it enters the expansion phase. The algorithm checks the node's neighbors, which are the nodes directly connected towards the graph. These neighboring nodes are then added to the open list. We are putting it in the open list, indicating that they are discovered but not yet fully explored. After expanding the current node and adding it to the children to the open list, the current node is moved to the closed node, that we are not we're calling it as the closed list, signifying that it has been fully explored. This step ensures that the algorithm keeps track of which nodes have been visited and avoids unnecessary re-expansion of nodes already explored. So, in the fourth step is the repeat. We have to repeat the process. The algorithm proceeds by repeating the steps 2 and 3, the previous steps in the loop. During each iteration, the node with the smallest heuristic value is selected from the open list and it is expanded to explore its children. This process continues until one of two conditions is met. The first condition is the goal. The goal is selected for expansion, which means the algorithm has found a solution and can stop. The second step is the open list becomes empty, which indicates that there are no more nodes to expand and the goal node is unreachable. This repetition ensures that algorithm systematically explores and explores the nodes in the graph while always focusing on the nodes that are closest to the goal according to the heuristic value. Next step is the last step, reach the goal or failure. There may be two choices, either we are reaching the goal or maybe a failure. Finally, after repeatedly expanding nodes, the algorithm reaches one of two possible outcomes. So what are all the possible outcomes, or the success or failure? If the goal node is reached, the algorithm can trace the path from the goal node back to the start node, reconstructing the sequence of nodes traversed during the search. This provides the solution path. If the open list becomes no empty, becomes finding that is empty without finding the goal, it means that there is no valid path from the start node to the goal, and the algorithm concludes that the goal is unreachable. This step serves as the conclusion of the search process, determining whether the algorithm has successfully found a path to the goal or whether it has failed to find the path. There are two options only, either success or failure. If it has been reaching the goal, we are calling it as success. Otherwise, we are calling it as the failure. We'll see one example problem. So this graph, this is the graph with the heuristic values. Here, these are all the values. We are calling it as the heuristic values. This structure presented in this presentation with the nodes and edges are here labeled. Each node has a heuristic value. Heuristic value, we are representing it as h of n, which is the estimated cost to reach the goal node from that node. The heuristic values are usually by the greedy best first search algorithm is to prioritize the nodes for expansion. The goal node, here we are considering this I node as the goal node, and it has got the lowest heuristic value. Here the h value is, for this value is 1, indicating that it is the closest to the goal according to the heuristic. Next step is, we are step by step we are going to follow this GBFS process. The first step is the starting. So this is the value has been given, heuristic values for each node has been given for A6, B4, C2 in this graph. Sometimes you'll be given with the graph, or sometimes you'll be given with the table like this. So the algorithm begins at the start node. So this is the table for the corresponding graph. And your first step is start node. We are going to start with the start node A. The algorithm begins at the start node A. This A node, we are calling it as the start node, and places in the open list which contains nodes to be expanded. Here A has been put it in the open list A. Open list is equal to A, which contains node to be expanded. The closed list is in this condition. What is the closed list value? Value is empty. At the start node. In the start node, this value is empty over here. And step 2, expand the node A. In the second step, we are expanding the node A. Node A is expanded. The algorithm evaluates its children. For all the children for this A, B, and C. The heuristic value for B is 4 and C is H is equal to 2. Since C, which value has the B or C is having a lowest value, C is having the lowest value. Since C has the smallest heuristic value, the algorithm chooses to expand C next. The node A is then moved to the node A is moved to the where it has been moving. If the C, it has to move into the closest list. And then open list now contains the values B and C. The open list contains the B and C. In the closed list, A will be moving. So we have to write like this: closed list and the open list. In the open list, we are keeping the values B and C, and A is moved to the closed list. In the step 3, we have to expand the node C. because it has got the lowest value, lowest heuristic value. Expand the node C. Node C is now expanded. Its children are, who are all the children? F and G. F has the smallest heuristic value. What is the H value here? 3. For G, the H value is 4. So it is selected for expansion. Node C now will be moving into the closed list. Moved to the closed list, and the open list now contains the values are B, F and G. Correct? B, F and G will be there. Next, we have to expand what? F to be expanded. This is the fourth step. We have to expand the value F. Correct? Node F has how many children? There's no children for this F. There's no children at all. So we have to, this step is we have to expand the node F. There's no children for F. So it is moved to the, where it has to be moved? It has to be moved into the closed list. Then the algorithm proceeds with the remaining nodes in the open list. The open lists are B and G. Available open lists are B and G's are available in this step 5. Next, if you're opening, expand the step 5, expand the, that is, expand the node G. Node G also has no children, so it is moved to the closed list. And open list now contains the only node B. Node B is expanded next as its children are D, that is D and E, correct? What is the heuristic value for D? 7, and the heuristic value for E is 5. Since E has the smaller heuristic value, what is the value comparing to 7? E is having the lowest heuristic value. It is selected for expansion. Node B is moved to the closed list. That is node B is moved to the, and open list now contains node D and D, correct? And next step is, so the sixth, sorry, expands the node B. Node B is expanded next. D has value 7, E has value 5. Since E has smaller heuristic value, it is selected for expansion. Node B is moved to the closed list. Next step, step 6. Node B is moved into the, where it is more closed list, and the open list now contains the node D and E, correct? D and E, and we have to expand. So this is moved into the closed list, and open list contain D and E only. And the seventh step is we have to expand the node E. Node E is expanded. Node E is expanded, and it is, its child is I, only one value. The heuristic value is 1 for this I. Since I has the smallest heuristic value, it is selected for expansion. Node E is moved into the, where it will be moving? Moved into the closed list, and the open list now contains just node I alone. What is the next step? Final step, step 8, expand I. We know that I is reached. The goal is expand node I. The goal is reached now. I is the goal node. Finally, node I, the goal node is expanded. This node will be expanded. Since node I is the goal, the algorithm, because this is the goal node, the algorithm, since the I is the goal, the algorithm stops and the path is traced back from I to A. Goal is reached now. Next one. So in this way, what is the final path here? The final path, and summary will see to it. The final path from start A to the goal node I is A to C, C to F, F to G, B to G to B, and B to E, then finally reaching whatever the value it is available in this closest list we are taking. This is the path found by greedy best first search algorithm based on the How these values are selected? Based on the heuristic values. Based on the heuristic values, we have found out heuristic values. We are finding out this path. The key idea behind GBFS is that it always expands the node that appears to be closest to the goal. That is based on the heuristic value without considering the actual cost to reach that goal. What are all the key takeaway points from this explanation? It is a heuristic driven. The algorithm always selects the node with the smallest heuristic value, aiming to get closer to the goal. The heuristic guides the search, making it more efficient in terms of perceived proximity to the goal. Next, no path consideration. In this case, what it represents, no path GBFS only looks at the heuristic values and does not consider the cost of the path taken to reach each node. This can lead to suboptimal paths since it does not account for the actual effort needed to traverse the nodes. And finally, non-optimal in some cases. Although greedy best first search often finds a solution quickly, it can sometimes find paths that are not the shortest or most efficient because it ignores the real path cost and only follows the heuristic guidance, that is cost value of that particular node. Hope everyone understood this algorithm. Greedy best first search, step by step we have discussed. The remaining things we'll discuss in the next lecture. Thank you.